The map on the right is an isoline map showcasing temperatures. Each of those temperatures are shown on a particular line. For example, right through here is 51 degrees, and so this is an isotherm line showing all points along this line have an average annual temperature of 51 degrees. This was measured from 1890 to 1980. All of these particular patterns are the same, although the numbers are just a little bit higher, maybe 1 or 2 degrees today. But nonetheless, the pattern still is the same. What we see here is a few different things that is discussed previously up above. First off, we see the influence of latitude. For the most part, as we go south, we see an increase in temperature, and this relates to the increasing solar intensity because of a higher sun angle and a longer day length on average down there in the southern part of the state versus the northern part of the state. But we can also see the influence of the maritime locations. So right through here, where we see Lake Michigan, we see temperatures are warmer in the northwest corner of Indiana versus the northeast corner. And this is all due to the moderating influences of a water body. In this case, Lake Michigan water really does a good job of moderating temperatures, especially in the winter. And so what happens is, yeah, it's really cold up in Chicagoland, but the lake actually helps those areas right along the lake to be otherwise warmer than they would be. And so this helps to kind of create this wonky pattern where we have, wait a minute, 48, 49, 50. What happens here is the line goes kind of around and back through here and comes back. And so all points through here are somewhere in the 49-degree area. And so 49 to 50. That's what that's showcasing here. So it's actually warmer as you get closer to the lake than it is down in this particular area where my cursor is here. Now we also have the influence of upland areas. And this is seen in two different areas for the most part. We can see upland areas over here on this elevation map that we've used beforehand, and of course the upland area here in south central Indiana. And so what this means is, okay, if I'm going to stay on the 51-degree line, because I'm going up in elevation, and as we know, when we go up in elevation, temperature goes down. What ends up happening is I have to go to a more southern location, or I have to go closer to the equator to find a warm enough location that stays 51 degrees. So if it wasn't for this upland area, if this is all completely flat, this would be 51 degrees straight across. However, because we have an elevated area right through here where these recessional moraines are, this elevated area, essentially what happens is I have to go to a more southern, or I have to change my latitude to stay at 51 degrees. The same idea applies here in southern Indiana, where we have the Crawford Upland and the Mitchell Plain. In this particular Norman Upland, this particular area of south central Indiana. This is very much an upland area. And so let's look at the 55-degree line. Notice how I'm coming across. And essentially, once I get to the upland area, I have to now go to a more southern location, or I have to find a more southern latitude to get to or to stay at 55 degrees. And so here's a way we can use this particular map to showcase the influence of water bodies, but also the influence of elevation, along with, of course, latitude.